There's a lot of discussion about what's the best Wordle starting word, but what I want to know is what is the optimal starting word if we want to get the answer in two as often as possible, and how much of an edge does that actually give us? Well, first we need to talk about what is the math behind that. How does that actually work? So, first of all, I'm going to tell you it's actually very easy to score, especially compared to the actual optimal starting word. We'll get to that. But what are we going to do here? Well, when we guess a starting word, we get a color pattern, and then we choose one candidate answer for guess two, right? So if I guessed crane, I might get this color pattern against whatever the current answer is, a green C, a yellow A, and then gray R, N, and E. So different answers will produce different patterns. And so what we want to do is we want to go through every possible answer, figure out what all the different possible unique colorings there are that we'll encounter, and then use that information to create buckets of, okay, if you're in this color pattern, that puts you in this bucket. Here are the possible answers that remain. And now the question is, what's the math there? How do we determine, okay, is it maximizing the buckets? Does it have to do with the size of the buckets? Maybe we need to average the size of the buckets. Maybe we need to have a lot of small buckets and one big one so that a lot of them happen in one, there's only one choice. What is it, right? Well, let's do the math. So we're going to define some terms here. First of all, we have our answer list. This is all the possible true answers. Now, this isn't everything you can guess. This is just words that are most likely to be an answer. And to do this process, I extracted the answer list from the official Wordle bot. It has a list of things it considers to be possible answers, and I extracted from there. It's somewhere around 3,000 words. And so what we're going to say is that the size of the answer list set, that's what this means, the size of the set, is just, we're just going to call that n, and we're going to assume every answer is equally likely. And so just from that set of answer lists, every day it's picking a random word from that list. And so this is just some fancy math that says we're defining A sub P, P being a pattern, not a probability, A sub P, little p, is just saying this is a set that contains all of the answers that match the pattern P. All right. So each non-empty pattern P creates one bucket, A sub P. So here's a sort of a visualization here. This pattern here might have 5 answers, like catch, cabin, cacao. Pattern 2 might have 3 answers, major, basil, title. And pattern 3 might have 2 answers, brink and drink. This isn't real. This is just an example. And once you get into there, you only have one possible way to win in 2, right? You got to pick, like maybe the answer was cabin. You have to pick cabin out of this list of 5. If you get into this one, you just have to pick maybe brink out of this out of this set of 2. All right, so let's calculate the probability then. So the probability of landing in a certain pattern is the size of A sub P. So the number of words in that bucket divided by the total number of words, right? In order to get into that bucket, we need the answer to be one of the words in that bucket. So the probability of that increases as the size of that bucket increases. And we end up with this simple division here. Now, what is the probability that we're going to solve on guess 2, given that we got a certain pattern? So we already know it's that pattern. What's the probability we're going to be able to pick the answer out of that pattern? Well, it's just 1 divided by the number of words in that pattern. So if there's only one word that matches that pattern, we have a 100% chance. If there's 2 words that match the pattern, we have a 50% chance. If there's 10 words, we have a 1 in 10, right? And so what we can do is we can just multiply those to get the total probability contribution of each bucket P. That's going to be, I'm going to bring it over to here. It's going to be the size of the number of answers in the bucket divided by the total number of answers. That's the probability of getting that pattern at all, multiplied by the probability of picking out that pattern or picking out the word now that we know the pattern. And we just multiply those together, and you will notice that these two cancel out. And when we want to find the probability of solving in 2, we just need to sum over all of the possible patterns that will happen for that word. And so that's just summing over the patterns, and these cancel out. That's just 1 divided by the total number of answer words. Suddenly, the size of the bucket has disappeared. This is just how many buckets did we get divided by the total number of answers. Well, that's very simple. We don't even have to worry about what words went into what buckets. All we need to do is calculate how many buckets did this word create, like how many possible patterns are created by all the available answers, and then divide that by how many answers there are, and that's going to be the probability of getting it in 2 with that starting word. And so that's our score. Here's an example. So let's say from before we had pattern 1 with 5 options. The chance that the bucket occurs is 5 out of 10 because there's 10 words. 5 plus 3 plus 2 is 10, right? We're just assuming it's a much smaller example, right? So if there's only 10 total words and 5 of them go into pattern 1, then there's a 50% chance, 5 out of 10 chance that you're going to actually get that pattern. And the chance, once you get that pattern, the chance of actually picking out the correct word is 1 in 5. There's 5 words in the bucket. And so its contribution is 5 out of 10 times 1 out of 5. The 5s cancel out. We end up with 1 out of 10. Pattern 2 might have size 3. It has a 3 out of 10 chance of happening, but there's a 1 in 3 chance of picking out the correct answer if it does happen. Contribution's 1 out of 10. Pattern 3 also has contribution 1 out of 10, meaning we have a total chance of 3 out of 10 of getting the correct answer, which is our B divided by the size of A. So that's our score. Our score is just how many buckets does the word create, and that's divided by the total number of answers, which means we really just have to track how many buckets does this word create. The one that creates the most buckets is the highest chance of getting it in 2. Now, so that means that the practical algorithm here is we're going to color every starting word against every possible answer and then count the unique color patterns. All right, so what this does not prove that this is the best Wordle starting word. I did mention that at the start. This is a much simpler problem. It optimizes to only one goal, the chance of solving on guess 2. For average guesses, the later branches of the decision tree matter. If we're trying to minimize how many guesses we're going to have to make in order to get to the answer, we create an entire decision tree, and every bucket then creates its own set of buckets, which then create their own set of buckets, and it gets very complex. And the only way to really analyze this is to generate the entire tree. And just because a word creates many first order buckets doesn't mean that those buckets aren't themselves awkward in terms of their size or the availability of words that will split it further into more buckets, that sort of thing. So that means that the words that optimize you to get it in 2 does not mean it's going to optimize your average number of guesses over time. All right, well, with all that said, drum roll please, here are the results. We've got pert is the winner. Pert means lively or excited. Someone is feeling very pert. Now, what's this color coding mean? Well, the white words are not actually on the answer list. So if you start with pert, it creates 158 buckets, which is the most buckets. And it's got a 5.31% chance then of getting it in 2, which means you're going to have a better than every 20 games getting it in 2 if you start with pert, which is pretty good. I don't know what you were expecting, but I think that was higher than I expected. However, pert is not on the answer list, meaning you will never get it in 1 if you start with pert. Salet here, or salé, however you want to say that. It's at 157 buckets. Salé is often cited as the best starting word. It's not a surprise that it's near the top, but it's interesting that it's not number 1. And so it's got a slightly lower chance. Tarse here has a 156. Now, I put slate and green, and any green ones are actually on the answer list. And that's slate here. So slate is the winner. If you want a chance to get it in 1, but you want to otherwise maximize getting it in 2. And that is why slate often shows up as the best Wordle starting word, because 1, they're only considering ones that are on the answer list. And 2, they are using this heuristic algorithm to calculate the best word rather than full decision tree expansion. All right, so that was your answer. And if you're curious, The absolute worst Wordle starting word is kayak, for getting it in 2. That only creates 20 buckets. You may recognize some of these words if you play Don't Wordle. We've got kayak, we've got pizzazz, we've got XVIII, just 13 in Roman numerals for some reason is accepted. We've got jujus, we've got ayaya, we've got zhuzh, we've got iwis, or iwis, I don't know how that's pronounced. Xylil is very famous. Ricks, whatever that is. Zezes. Now, some of these words here are not accepted by Don't Wordle, because Don't Wordle doesn't have the full list of accepted words that Wordle currently does. But if you're playing Wordle and you want a challenge, you could start with one of those. All right, now, I know there's a burning question in your mind, because it was burning in my mind as well. What is the theoretical maximum number of buckets? Well, I can give you an upper bound, which is 243. That is just, there are 3 possible colors per slot. There's 5 slots. 3 to the 5th power is 243. So theoretically, there could be some starting letter pattern, some starting word that is going to give you 243 buckets. So I had that question too. What if you could actually just type whatever you wanted in Wordle? It didn't have to be a valid word. You could just type whatever you wanted. How many buckets could you get then? How high could we make this chance? Could we get all the way to 243? Well, here you go. No, you can't. You can get to 161. So it's slightly better, a 5.42% chance instead of 5.31. These ones in gray are not accepted by Wordle. If you try to start with these, it will not accept it. But if you were playing a version of Wordle where the only difference was it'll accept anything you type, then Kirt, would you pronounce that Kurt, Kirt, Seert? I don't know. It's not a real word, so we can make up our pronunciation. That would be optimal, or Saret. They're equally good. And you'll notice that actually Kirt, Katre, Create, Creat, they're all anagrams of trace, which was previously considered the best for getting it in 2. Now, if we scroll down, we eventually reach trace at number 47. If we're only considering words that Wordle accepts, trace is at number 11. So trace has been dethroned for Pert, or maybe Kurt, if you would like. And so this actually means that you'll notice a lot of these are Salet anagrams. A lot of them are trace anagrams. This is a stair anagram. So just the placement of the letters can make a small difference in the number of buckets that you end up with. So there you go. If you want a best chance of getting into 2, start with Pert. But be careful, because just because you have the best chance of getting in 2 does not mean that your average number of guesses is going to be as good. And so generally something like Salet is going to do very well for you in terms of full decision tree analysis, and it's only slightly less chance to get it in 2. So, or you could go all the way down to Slate if you want to have a chance of getting it in 1, or really any of these. Probably won't be recognizably different. All right, well, hope you enjoyed this, and see you in the next video.